Welcome back to Logical Thinking, and in this video I'm going to talk about formal fallacies. Now, a fallacy is a fancy way of saying an error in logic. In fact, the word fallacy is related to the word fail. So a fallacious argument is an argument that fails for one reason or another. Now, we often distinguish between formal fallacies and informal fallacies. And a formal fallacy is an explicit error in the structure of the argument, meaning it's an invalid argument, whereas an informal fallacy is an unsound argument. The structure may be valid, but it has an unacceptable premise that causes the conclusion to not necessarily follow. So this is the difference. In this video, we're mostly going to be focusing on formal fallacies because we've been talking about argument structure, and you'll find that a lot of these formal fallacies are really close to a valid argument structure, but maybe something's flipped or switched so the conclusion doesn't logically follow. Now, one thing that's important to remember is fallacious arguments may still have a true conclusion. This is true for both formal fallacies and informal fallacies. I mean, I can give a bad argument for things that are true. For instance, I may say the earth is round because 2 + 2 = 4. And this is a total non sequitur. The conclusion does not follow from the premises, but that doesn't make the earth flat. So that's a distinction between bad arguments and sort of bad or untrue conclusions. Those are two kind of different things. And basically, to see whether an argument commits a formal fallacy, you can look at a truth table and see if the conclusion logically follows from the premises or from the conjunction of the premises. So there are going to be 4 formal fallacies we talk about in this video, and don't be scared off by these words because I'll explain what they mean and show you how they're very related to other types of arguments. And those include affirming the consequent, denying the antecedent, affirming a disjunct, and denying a conjunct. So first, affirming the consequent. Imagine we have an argument of the form A implies B. Consider this. We have a truth table, A, B, and A implies B. This is what we typically have. Remember, A implies B is true everywhere except when the antecedent A is true and the consequent B is false. And one example here is if we let A be the proposition that I can drive my car. This is not actually my car, and B is the proposition that my car's engine working properly. Saying A implies B is like saying, if I can drive my car, then the engine is working properly. And this would be a true statement. This makes a lot of sense, right? If I can drive my car, then the engine must be working, because if the engine isn't working, I wouldn't be able to drive my car. Now, affirming the consequent would be like saying, if my engine is working properly, then I can drive my car. Now, the reason this is wrong is we haven't said anything else about the other things that could keep me from driving my car. And this will become clear a little later when we talk about necessary and sufficient conditions. But think about it like this. Perhaps my engine is fine, but I can't drive my car because it has missing tires. Maybe I can't drive it because someone stole it. Remember, A implies B is true in cases when A is false and B is true. We haven't ruled out these cases yet. So it's wrong to conclude that because A implies B, B somehow implies A. Now, the way to fix this is to rule out all the other possibilities. For instance, if you were to say, if my engine is working properly and there's nothing else out of the ordinary, then I can drive my car. So remember that A implies B doesn't say anything about A being the only way B can happen. There might be other ways B can be true other than just A. So be sure not to flip these. And if you look here, this is the problem that happens when you affirm the consequent. Affirming the consequent looks a lot like modus ponens, so be careful not to confuse the two. Modus ponens produces a valid argument, whereas affirming the consequent does not. So modus ponens says, premise 1, A implies B, premise 2, A, and our conclusion is therefore B. So this is like saying, if I can drive my car, then the engine must be working properly. Premise 2 says, I can drive my car, so then I can conclude that therefore my engine is working properly. Whereas affirming the consequent goes like this. Premise 1, A implies B, premise 2, B, and then our conclusion is therefore A. So this would be like saying, look, if I can drive my car, then the engine is working properly. My engine is working properly, therefore I can drive my car. And we can ask, does this conclusion follow from premise 1 and premise 2? So let's first look at A implies B, our first premise. This is false in line 2 of our truth table, so we can go ahead and cross it out. Now let's look at our second premise. Our second premise is false in that last row of the truth table and the second row that we already crossed out. So let's go ahead and cross that out as well. And let's see if the conjunction of premise 1 and premise 2 give us our desired conclusion. We have 2 rows remaining, and notice that A is true in that first row, but it's false in the second. So this is the problem. The problem is that we don't have that the conclusion follows. The conclusion is kind of underdetermined by the form of the argument. So this is where we say affirming the consequent is a fallacious form of argument because the conclusion does not logically follow from the premises. Now we're going to talk about denying the antecedent. Just like how affirming the consequent is an error that looks like modus ponens, denying the antecedent is an error that looks like modus tollens. So let's go ahead and first look at what modus tollens is so you don't get confused. Modus tollens is a valid form of argument, as we showed in our previous video, which goes like this. Premise 1, A implies B. Premise 2, not B, and our conclusion is therefore not A. So this is like saying, if I can drive my car, then the engine is working properly. My engine is not working properly, and as a result, therefore I can't drive my car. Affirming the consequent is a fallacious version, and it goes like this. Has the same premise 1, A implies B, except it says not A, and then it tries to conclude therefore not B. And it would be like saying this. Look, if I can drive my car, then the engine is working properly. I can't drive my car, and therefore my engine is not working properly. And we can ask, does our conclusion follow from premise 1 and premise 2? And obviously in this example, this is not the case. I can't conclude that just because I can't drive my car, the engine is broken. It may be the case that my engine is working fine, but I can't drive my car for some other reason. You know, perhaps the tires are missing or someone stole it, right? If someone stole it, obviously the engine was working just for them to take it. So let's show why this is the case. Looking at our truth table here, this is A, B, and A implies B. Looking first at premise 1, where A implies B. This is once again true everywhere except this second row, so we're going to cross this out. And looking at our second premise, not A, this is true in rows 1 and 2 and false everywhere else. Remember, we're crossing not A out where not A is false, meaning when A is true. And this is these first 2 rows, so we cross this out. And we have 2 rows remaining, and we can ask, does it follow that B is false? And sure enough, it does not follow. And the main problem here is that third row in the truth table. This is a case where there's an option where B is in fact true, where not B is false. So not B does not follow from premise 1 and premise 2. So this is why denying the antecedent is a fallacy. Now we're going to talk about affirming a disjunct. And I think this is the one that's perhaps the most excusable out of all the fallacies. Affirming a disjunction is similar to the disjunctive syllogism, but it occurs when we make the mistake in thinking that knowing something about one proposition tells us something about the other. So think about it like this. Let A be the proposition that I will ride Top Thrill 2, and B be the proposition that I will ride Valraven. The disjunctive syllogism goes like this. Premise 1, A or B. Premise 2, not A, and then our conclusion is therefore B. This is like saying, look, I will ride Top Thrill 2 or Valraven, and then I say I will not ride Top Thrill 2, so therefore I will ride Valraven. This is the conclusion that logically follows from premise 1 and premise 2. If you remember, we showed that this was a valid form of argument in a previous video. Now, affirming a disjunct is fallacious, and the reason it's fallacious will become clear in a second, but it's like this. Premise 1, A or B. Premise 2, A, and then the conclusion is therefore not B. So this often occurs because people think that that logical or behaves in an exclusive manner, and it doesn't. So this is why this doesn't follow. So this is like saying, look, I will ride Top Thrill 2 or Valraven. Premise 2 says I will ride Top Thrill 2, and then the fallacious conclusion is therefore I will not ride Valraven. So to show why this is wrong, consider the truth table. We have A, B, and A or B. So A or B, once again, is true everywhere, except when A and B are both false, which is that last row in the truth table. And let's look at premise 1 and premise 2 taken together. So premise 1 tells us A or B, which is true everywhere except that last row, so we're going to cross that out. And premise 2 tells us A, which means we're going to cross out where A is false, which is those last 2 rows of the truth table, which we're going to cross out. And then we ask, does not B follow? Does it follow that B is false? Well, it's false in that second row of the truth table, but it's not false in that first row, meaning we can't conclude not B from the conjunction of premise 1 and premise 2. And this is why this is a fallacious form of argument. The problem is that first row in the truth table. A or B is true when A and B are both true. So therefore, we can't rule out B even if A is true. So we say no. Affirming a disjunct is a fallacious form of argument because the conclusion does not follow from the premises. Now we're going to talk about denying a conjunct. This occurs when we create a false dichotomy between 2 options and we don't allow neither of them to be false. Now let's look at denying a conjunct in the context of a disjunctive syllogism with De Morgan's law applied. So a disjunctive syllogism goes like this, not A and B, and premise 2 tells us A, and therefore we conclude not B. So this is like saying, look, I won't order both fries and onion rings. I'll order fries, and therefore I can conclude that I won't order onion rings from this. Denying a conjunct goes like this. Not A and B, so premise 1 is the same, but we say not A, and then we conclude therefore not B, which is not correct. This is like saying, I won't order both fries and onion rings. Premise 2 would be like, I won't order fries, and the wrong conclusion would be to say, therefore, I won't order onion rings. But that's not the case. If I don't order fries, that actually doesn't tell me anything about whether I order onion rings or not. If I don't order fries and order onion rings, it's still the case that I wouldn't order both fries and onion rings. So this is why this doesn't quite follow. So let's go ahead and look at the truth table. We're going to have A, B, and A and B, because this is a conjunction or a conjunct. And let's go ahead and look at premise 1. So premise 1 tells us not A and B. So we're going to cross out wherever A and B is true because we want the negation of this to be true. That's that first row. So we're going to cross that out. And premise 2 tells us not A. So we're going to cross out wherever A is true because we need not A to be true. So whenever not A is false or A is true, we can't have this either. So we're going to go ahead and find these 2 rows and cross them out. And now we can ask, does it follow that B is false? Does not B follow from these 2 premises? And if we look at both of these, this is not the case. That last row is fine, but it's this third row that gives us the problem where B can still be true if not A and B is true and not A is true. So that's the problem there in that third row. So does our conclusion follow from premise 1 and premise 2? No. Now, there are other types of formal fallacies that can often be derived from these basic ideas. And one is, for instance, the fallacy of the undistributed middle term, which we'll talk about later. This can often be reduced to an argument that either affirms the consequent or denies the antecedent. But an example of this would be like, for instance, premise 1, all students wear backpacks. Premise 2, my grandfather wears a backpack, therefore my grandfather is a student. This is wrong once again because you're not saying all students wear backpacks and all backpack wearers are students. So once again, you get that affirming the consequent where you flip the implication there. And then you have the fallacy of 4 terms, which is kind of a form of a non sequitur where you introduce a 4th term into a syllogism that isn't really related. And as a result, your conclusion doesn't follow. So this would be like saying, look, all fish have fins, all goldfish are fish, and therefore all humans have fins. You can say, look, premise 1 is like saying A implies B, fish are A and fins are B. Premise 2 is like saying C implies A. And then the conclusion is like saying D implies B. Humans would be D. That's a 4th term, which once again doesn't have any sort of logical connection to them. So that's the problem with that. So once again, you want to be sure to look at the structure of your argument, make sure your conclusion logically follows. Thanks for watching, and I will see you in the next video.